Welcome to TXOGA Talks, where energy meets insight. The purpose of this podcast is to provide you with a candid conversation about our energy needs, our energy security, and your energy future. Texas oil and natural gas have made our nation the world's energy leader, constantly innovating and investing to fuel the economy, protect the environment, and power the world. This industry is fast-paced, high-tech, and essential to improving modern life. And we're here to talk about it. You're listening to TXOGA Talks, where energy meets insight. Well, thanks so much for joining us again today for another episode of TXOGA Talks. Now, normally, I have the Director of Government Regulatory Affairs here with me to talk about all things oil and gas on the steps of the Texas State Capitol. But today I'm joined by the Vice President of Government and Regulatory Affairs. Shana, congratulations.
Thank you. Thank you for the promotion. I appreciate it.
Well, you're doing a great job. You're jumping in. You work on a variety of issues. And it's all the things that are needed to enable the modern day oil and gas companies to meet the needs of not only Texans, but the world today. So I'm excited that we have these times for these candid conversations.
Absolutely. Today we're going to have our first interview. So it's a big day. And we're going to be talking about the upstream sector of the oil and natural gas industry. We've done an episode before, the 4Ps episode, where we talked about the 4Ps: production, pipelines, processing, ports.
You're good.
If you're interested in learning more about those, you can check them out on our website and go back and listen to that episode. Today, we'll just be focusing on that upstream production P.
In fact, all of our episodes are recorded for you to look at and listen to. I listened to episode 6 that I missed out on, and I really hated to because about LNG, and you and Dr. Foreman did a great job.
That's right. And I know there's so much going on in that space. So if you're interested in learning a little bit more about LNG and our perspective on that, Dr. Foreman had a really great paper. So we encourage you to go and listen to that as well.
Well, today you mentioned we're talking about the upstream sector. Oil and gas is very complex, but it's also divided into industry sectors, and there's different disciplines. And upstream is kind of where it all begins. And so it's going to be a very good conversation about Texas upstream here today.
Today, we have two experts with us. We have Nathan Luoma, who is the Vice President of Production, and Hunter Landers, the Senior Vice President of Completions from Diamondback Energy. Diamondback is a TXOGA member company and an oil and gas producer based in Midland with upstream operations across the Permian Basin.
And Diamondback has had some big news. Welcome, Nathan and Hunter. We're glad to have you.
Thank you for having us.
Good deal. Yeah. Y'all have just announced a merger with Endeavor here not too long ago. That's exciting news. And I've been reading some other areas that you've been involved in. So we're glad to have a conversation with you today. And your titles that you have actually reflect different functions of oil and gas production: drilling, processing, completion. And I think that's very interesting how that all fits very nicely.
Absolutely. And so I think let's dive right in. Diamondback primarily operates in the Permian Basin, which is the highest producing oil field in the U.S. We've talked about that on different episodes. So Nathan, could you take a minute to explain to our listeners who might not be too familiar with the Permian Basin region, how important it is, how big it is, and why that's where Diamondback operates?
Yeah, sure. I think, first of all, it's just the massive size of the Permian Basin. I had to look this up, but 75,000 square miles is the whole Permian Basin, which, would make it, if it was its own state, the 18th largest state, just a little bit bigger than Washington State. So a very big land position, spread out, and then Permian produces 6 million barrels of the almost 13 million barrels that the U.S. produces. So half of the barrels produced in the U.S. come out of the Permian. So that's a huge, important resource. Only Russia and Saudi Arabia would be countries that produce more than the Permian does. So I think that cements the Permian as a very important region. We're blessed with stacked pay, 2,500 foot thick, 5 to 10 viable different pay zones stacked in a lot of the basins. So those are just the unconventional zones. We've got conventional zones that have been drilled out here since, the 1920s. So
now, Nathan, you use the word conventional and unconventional. For those that may not be well versed in that, can you kind of explain what that might mean to them?
Yeah, conventional reservoir, we could drill mostly vertical wells and they would produce at an economic rate and be economically viable with a small frac job or an acid job or something like that. So higher permeability rock and was able to be drained without going horizontally. Unconventional, it's really the source rock where the oil first came from and migrated into the conventional reservoirs. And we're going into that source rock that doesn't produce economically without going horizontal and putting large frac jobs on that rock.
So conventional, the traditional vertical drilling, unconventional horizontal drilling combined with hydraulic fracturing. That's great for our listeners to grasp that, I think. And we talk a lot about E&P in the industry, and all this terminology is secondhand nature to you guys. What does E&P stand for? And can you give a little quick description, maybe one of you, about each one of those activities?
Yeah, so exploration and production is what it stands for. So the exploration side would probably relate more to the discovery of oil and gas reserves. And production is operating the fields. And after you drill and complete and start producing those wells, how you operate them and how you effectively draw down and maximize the recovery of those assets. And I'm sure this falls into one of the categories broadly, but I think something that we're more familiar with today is development that would be more applicable to today's activity, especially in the unconventional basins, the activity that's going on in the Permian and many other basins across the United States. And the development piece, I look at exploration as finding something. So you may be drilling a well with a high degree of uncertainty to try to discover a resource. And development is when you've already discovered the resource, which in most of the Permian Basin and most of the activity that's being drilled and completed, the resource is discovered. It's a matter of developing it and maximizing the recovery of that resource. And so we have in unconventional resources, we have a very high success rate and consistency because we know the resource is there. It's just a matter of developing the strategy to most effectively develop that resource and get the most out of it.
How big is the team that works to locate the place that you drill? And you could talk about it from a development or from an exploration point of view.
Really, the team that works on where to drill is our geologists, geophysicists, hydrophysicists, and reservoir engineers. And that, for us, is around a 60 employee team. And they're really working on, where do we drill? How far do we space the wells from each other? And all of that plan.
That's a big team, and it's an important part of the process, obviously, to get that right. One thing I think when we're discussing the Permian Basin, that includes Texas and New Mexico, and not everyone recognizes that. When we hear us talking about the Permian in Texas, Texans think everything's in Texas, and so we're glad to have partners this, and we know that a couple of counties in New Mexico are very, very big high producers as well.
So we talked a little bit about how you come to it. So how much is Diamondback producing on a daily, monthly, yearly basis?
Yeah, so we're making about 350 to 370,000 barrels of oil a day. So on a yearly basis, that's about 130 million barrels gross. 1.2 million barrels a day of water is being produced by us. A BCF of natural gas a day is getting produced. So that's kind of what we deal with day to day.
That's quite a bit, I would say.
You're in the water business as well as the oil and gas business. It's what it sounds like. And that's the reality. People don't recognize in any given well, there might be oil coming out, gas coming out, natural gas liquids, and in the Permian, a lot of water. And it's water that's been down there for years and years.
What hunter can use that on the completion side in a lot of cases in water recycling?
Hunter, your title is Senior VP of Completions. So kind of walk us through what completions means and what all it entails.
So completions is the process that occurs between the time that the drilling rig leaves and the time that the well starts producing oil, gas, and water. So basically anything that happens in that process. So I'll go to have a drilling person, but I'll take a shot at it. So on the drilling side, they're essentially drilling the hole. So they drill to the vertical depth of where the reservoir is, and then they kick off and build a curve and drill sideways into the target zone for anywhere up to 3 to 4 miles these days, horizontally.
Well, I get a lot of questions, and maybe you can address this. In the drilling, when you're drilling down through rock and you're going toward your pay zone, and pay zone meaning the resources that you're trying to recover, there's a lot of concerns about groundwater quality. People have questions about that. So in that process, what's done to protect that groundwater? Can you elaborate on that for just a second?
Yes. So, we have, practices that are in place that are, meant to protect groundwater. They're controlled by regulatory bodies in the state of Texas. You have a water board letter with your permit with the state to ensure that the planned depths and casing and cementing requirements are all set in place. The Railroad Commission has regulations as well that we all follow. And so what that entails is generally you have your first string of pipes. So it'll be a larger string, a larger diameter pipe that you set in the ground that is controlled by those regulatory bodies and the engineering teams that come together to figure out the right depth. They come up with a depth. They drill to that depth. They run pipe in the well and put cement around it. And that cement isolates that groundwater from being accessed by anything in that wellbore. Next, after that, they drill, depending on pressures in the zones that you're drilling down to, they'll drill to a next depth of just call it 5,000 feet. So the first depth is commonly anywhere from 300 to 400 to 2,000 feet to protect the groundwater, and there'll be a string of pipe across that. Then we call that surface casing. Next up, you'll drill down to another depth, depending on the different pressures of the different reservoirs in the area that you're drilling. And just for this example, we'll call it 6,000 feet. You'll set another string of pipe and cement it. So now the groundwater has that initial string of pipe plus cement behind it. It'll have a second string of steel pipe with cement around it. And then that third one, there could be a third and a fourth, but in most cases in the Midland Basin, it's just the third string, which we call the production pipe. That's what we actually produce the oil and gas up that pipe and eventually tubing inside of that to produce the well. So the third string is generally where we build the curve, or the third hole size is where we generally drill the curve and lateral. After that curve and lateral is drilled up to 2 to 4 miles out, you run the third string of pipe in the ground and cement that in place. And so that's a third barrier, if you will, across the freshwater zones. And also where we produce our oil and gas out of that string of pipe.
I think that's awesome, Hunter. And Shana, the important thing is for the public to recognize just what Hunter went through and described. There are multiple layers of steel and cement that are used specifically to protect that groundwater that we also rely upon. So there are a lot of resources that we rely upon, and I'm glad to know that oil and gas companies do such a good job in protecting that.
Absolutely. And I had a follow-up question. How long does it take to go through that process of putting all of that in?
Depending on the length of the lateral and the depth of the target zone, I think we've drilled wells start to finish in around 5 days, and then maybe average closer to 10, depending because of the longer laterals, but can be 5 to 10 days, which that's drastically decreased. And over the last 5 years, I can remember when we drilled vertical wells before kind of this horizontal revolution in the Permian, we used to take 20, 25 days to drill a 10,000 foot vertical well. Now we can drill 10,000 down and 10 to 15,000 out in 10 days. Once that is finished, that's when the completion process starts.
So we're going to take a quick break to hear from this week's sponsor, and when we come back, we'll dive more into this conversation. Today's episode is sponsored by TXOGA member company, Diamondback Energy, a Texas-based independent oil and natural gas company. Diamondback is focused on the acquisition, development, exploration, and exploitation of unconventional onshore oil and natural gas reserves in the Permian Basin in West Texas. At Diamondback, business success is achieved through disciplined commitment to a culture of excellence, efficiency, and low-cost structure, as well as a commitment to doing business in the right way, focused on integrity, leadership, excellence, people, and teamwork. To learn more about Diamondback, visit their website at diamondbackenergy.com.
Our job is to give access to the reservoir in the most efficient way possible, both in moving the fluid out of the reservoir into the wellbore, as well as on a cost basis. So what we do is we perforate holes, which is using small shaped explosive charges to basically punch holes in the wellbore. And so we run that in on electronic wire lines. So it's basically an electric cable wrapped in steel. And you have those perforating guns or those explosives tied to that wire line. You run it down until gravity stops it, and then you pump on it, and the friction of the fluid going around the wire line assembly will pull it down to the bottom of the well. When we get to the depth that we want, we will shoot the holes. So just for example, let's say we'll do 200 feet at a time, and we call it a stage. So we'll shoot a series of holes over 200 feet, and now there's holes in the pipe, and you have access to the producing reservoir. These unconventional rocks don't have the permeability when we talk about permeability, we're talking about the ability for the fluid to naturally move through the rock. So you won't be able to drain a big area by just punching holes into the reservoir and letting it seep into the reservoir. So that's when we start fracking. So fracking is pumping water at high pressures into the rock matrix until the rock fails and breaks. So fracturing. So that's where frac comes from. It's short for fracture. And we'll create these fractures, and then we'll mix sand with the water in chemical suite, and the sand will go into the fractures and prevent it from closing. So you place the sand inside the fractures, keeps them from closing, and now we have a bigger area. We used to just have a small area in a conventional reservoir, just the hole in the pipe, and it could drain. Now we have created a lot of surface area. That surface area can drain into the sand pack and then run through the sand pack all the way to the wellbore. And we generally do it in roughly, depending on the reservoir, 200 feet sections. So if you have a 10,000 foot lateral, you have to repeat that process 50 times to complete the entire lateral length of 10,000 feet in the well. You're kind of rinse and repeating that process 50 times. So you do that. You do 200 feet at a time, and then when you're done, you set up an isolation plug in between each one of those stages. So then we bring in a rig or a full tubing unit, and we drill those plugs out and clean all the additional sand that might be left over in the wellbore out, and we leave a nice clean wellbore for Nathan's team. And then generally, we already have a rig there, so we just go ahead and run the artificial lift that Nathan's talking about. And the reason you do that is kind of what he talked about is there's a associated weight of all the fluid, the water, the oil, the gas in the vertical section of the well. And the reservoir pressure at the bottom of the well may not be high enough to lift that fluid all the way up. And so in that case, we have to run the artificial lift. And the artificial lift essentially aids and assists that bottom hole pressure to be lower, which allows the reservoir pressure to drive fluid along that lateral to the formal artificial lift to lift it out of the wellbore. And so that's pretty much the completion process. Once we run that artificial lift, we turn it over to Nathan, but it's that portion of inheriting that nice clean wellbore with unperforated pipe and cement behind it. And we're gaining access to the reservoir and stimulating that reservoir to make it produce the maximum amount we can make it produce.
Well, Hunter, you just described a process that it includes hydraulic fracturing, which we read a lot in the press about as fracking. It didn't sound near as scary to me when you described the actual, physical components as what the mainstream media sometimes wants to make this out to be. So thank you for doing that. And I hope that some of our friends in the media take time to listen to that process, because it's just an engineering process that smart men and women have figured out, and you stay on top of, and you watch every step of the way. So thanks for doing that. You talked about the teams that go into the discovery and development. What about the production? How describe that process a little bit for us as well.
Yeah, so I'll cover the production kind of after the completions, and Hunter can go through the completions. But after the wells are fracked and drilled out, then oftentimes his team will run the first form of artificial lift if the wells don't flow automatically by themselves. And so if they don't flow automatically, we're going to run the first form of artificial lift, either electric submersible pump, or for us, we sometimes use high pressure annular gas lift. Those are our two main forms of lift right off the bat. So our job is really analyzing what's the form of lift that can get us the production rates we expect at the lowest cost. In the past, ESPs were kind of the only option for those initial high rates. And in some formations, now we can apply high pressure annular gas lift and get the same rates for much less complexity downhole mechanically and really lower our costs. We're really focused on how do we produce the wells to the lowest bottom hole pressure, make the most fluid flow out of the reservoir, and then do that at the lowest cost. So as the wells decline, we have to change. We have to continue to fix the artificial lift as it fails, and then take time to analyze when do we switch from, say, ESP to rod pump. When's the economic right point to switch?
So Nathan, you're not talking about just plugging and playing and turning on a switch and walking away. You're talking about a very thoughtful process, ones that is looked at constantly. You monitor these wells 24/7, I would suspect. Is that correct in your operations center?
Yeah, we have a remote operations center where we're monitoring the tank batteries as well as wells 24/7. And so, yes, you're constantly monitoring for power failures, for broken equipment, things like
pressures that are constant and changes. I think that's an area, Shana, that a lot of Texans just don't really understand how intensive this is, how safety is a priority, how the systems are utilized today and organized in such a way that companies can really watch those sites, know what's going on, be able to deploy resources as it's needed.
And these sites aren't, in town. You're traveling far. I think that's another concept. When you talked about the vastness of the Permian Basin, your sites are further out, and it takes time to get out there and check on things, right?
Yeah, I mean, we're operating 5,000 wells, over a very wide area. Our goal is 100% runtime. We never completely achieve that, but our goal is to be up and running, as many hours of the day as possible. So that is, we have to deploy assets, to fix things all the time, keep things online.
Shannon, something you and I were talking about was how many people today at a typical site that you might have, at a typical production site, how many would that be, would you say?
A lot of these well pads are not manned 24 hours a day. Like we're saying, we're remotely watching a lot of things. We've got about every company and production employee has about 10 to 20 wells. That if you were to just take all the production and divide it by how many wells we have. So 10 to 20 wells per person. So 5,000 wells, we've got a team of company employees around 400 that's over the field production. And then, any one time you could maybe have 200 or more contractors, either fixing power lines, fixing drives,
taking water, hauling water off of a site, right? Those kinds of things. That oil and gas has about 500,000, almost 500,000 direct employees working in Texas today. And Shana, these are some of the best paying jobs in Texas. It's amazing when you think about the average wage in the oil and gas industry as compared to the other typical private sector employers. It's not quite double, but in some instances it is. And that should be good news for people looking for jobs.
Absolutely. And I think, Nathan, you pointed out kind of some different jobs that maybe people don't think about, like a geologist that's looking at the formation of the rock and where to drill. And so I urge our listeners to check out, we actually have a career center, TXOGA's Career Center. You can go to careers.texoga.org and you might be able to find that next highly skilled, highly paying job in the oil and natural gas industry.
And we all send our kids to school for one reason, to get a job.
That's right.
And so that's a great site that you mentioned. And I'm real glad that we're able to make that available to companies that are looking for employees and for people that are looking for a job. And it's got some great assets because it will help you write a resume if you need help doing that. There's some tools there that people can use. What was that again?
That's careers.texoga.org.
Great.
How do the pump jacks that we see on the side of the road, how does that factor into the drilling process and the completion process?
That's really after the drilling and completion. So that's the production piece.
Okay.
That is, like I said, we kind of have three main forms of lift to get the fluids out of the well. The first forms of lift are ESPs and gas lift. And mostly because rod pumps just can't move as much rate as those other forms of lift. But rod pumps are a very cost-effective way to lift fluid once you're call it 700 barrels of fluid a day. So as the wells age and decline, we have to start trimming the costs on every well. And so we go to rod pump typically, somewhere between 300 and 700 barrels of fluid a day. And we're always trying to kind of push that conversion rate up higher because ESPs are very expensive. Mm-hmm. And so the sooner we can go to rod pump, the sooner we can lower our costs.
Well, because of all of this work, Texas is the fourth largest oil producing state. If we were our own country, we'd be the fourth largest country in producing oil, would be the third largest in producing natural gas. I kind of like the sound of Texas being its own country, but I won't get into that a little bit.
That's a conversation for a different day.
There you go.
So we're going to take a quick break to hear from this week's sponsor. And when we come back, we'll dive more into this conversation.
Hi, I'm Neil Carlton, president of the TXOGA Insurance Agency. The TXOGA Insurance Agency is pleased to sponsor today's episode of the TXOGA Talks podcast. TXOGA members have access to the TXOGA Safety Group with Texas Mutual and get a premium discount of 12.4%, as well as the possibility to earn 2 dividends. Participants also have access to unique safety tools to keep their team safe and on the job. Visit TXOGAinsurance.com for more information.
So I want to dive back in. We talked a little bit, I think Todd mentioned that the process that you described about fracking really isn't as scary as some people make it out to be. So I'm wondering if you could talk a little bit about your thoughts on that, because I know we have a lot of great resources out there. Fracking 101 from our friends at Texas for Natural Gas. But we'd love to hear some of your thoughts about that.
Yeah, I think a lot of people have seen, some popular documentaries that kind of outline or try to bring to light concerns about hydraulic fracturing. We talked a little bit about the casing programs, the cementing programs, the regulatory steps that are taken to protect groundwater. And then along with those, you have the actual, chemistry that's used to frack. So those have been the primary concerns, are contaminating groundwater that the documentaries that I've seen have addressed. And In reality, today, what we use to frack with is produced water. So a lot of times we recycle the produced water and use that, but it is cleaned. You have, measures to reduce bacteria. And along with that, when we're fracking, the common chemicals we use are surfactants, which the point of the surfactant is to reduce emulsions, right? So basically you're introducing water and oil, they don't mix, right? So it can create an emulsion, which can create production challenges, separation challenges on surface. But, surfactant's not doing the same job as your Dawn dish soap. When you have a greasy pan and you put Dawn dish soap in it dissolves the grease and makes it where it can be removed from the pan. Well, it's very similar. And the other common chemical we use are friction reducers because, believe it or not, water is kind of sticky. So it has a higher friction number. So it takes more pressure to push it down the wellbore. So we use friction reducers to minimize, the friction or the energy we have to expend to apply the pressure to make a fraction. But these chemicals are applied in very small quantities. So roughly, a half of a gallon of friction reducer to every 1,000 gallons of water, or a quarter of a gallon or half a gallon of surfactant to every 1,000 gallons of water. So same thing with the chemicals we use for bacteria. They're also, in a lot of cases, the same chemicals that municipal water are treated with for bacteria. And so if you were to go take a look at some of these chemicals in their raw form as they're presented a lot of times in these documentaries, they don't look great. But when you dilute it down to, 0.1 gallons for every 1,000 gallons of water that we pump, that's what we drink every day, treated at a municipal plant. So I kind of look at it like that. You may not like the chemical makeup in its raw form, and understandable. You wouldn't want to drink that chemical out of the bottle, but as it's applied to the chemistry, the biocides and things like that, they're diluted down to the point that they're not, as scary as people make them out to look. The other thing I'd kind of like to bring out is, like you said, all the protections that are in place, both regulatory and just general operators being responsible operators. We live in Midland, we drink the water, and we want to be responsible stewards, as does virtually the entire industry. We want to be responsible stewards of our environment because we live here, we drink the water, we breathe the air, and we want to do the right thing.
Education is so important, and this information that you guys are providing to us today, I think, sets the stage. What you just described are pretty much everyday products that we use in our homes. And the thing about the produced water and the hydraulic fracturing that's occurring, the water that you're pumping down along with those minute elements of those chemicals is either staying in that area where that oil and gas is located, or it's coming back up with produced water and it's being treated to appropriate regulatory required standards for health and safety. So the reason that the United States is energy secure today, the reason that we have affordable, reliable energy and we're not dependent on foreign countries is because of the work that's just been described here by Nathan and Hunter. It's pretty amazing.
I love the way that you described it and the example that you use for, when you're washing your dishes. And I really feel like science is leading the way here, science and technology. So Nathan and Hunter, is there anything else that you'd like to share with us today that we haven't touched on in that upstream process that you feel like our listeners should know?
We're talking about groundwater at 300-400 feet depth. And we're talking about fracking wells at the shallowest, maybe 6,500 feet depth. And we care a lot about just not fracking into a zone 200 or 300 feet away, because we don't want to drain the same rock we drilled another well for. We want them to drain their own area of rock. And we're making sure we don't frack into a zone 300 feet away, but we're talking about potentially fracking into a zone 6,000 feet away. It's just not physically possible unless you breach the casing, which we have 3 sets of casing as barriers. We've got cement. They're monitoring, the space between production casing and intermediate casing to see if there ever is a breach in the casing. The job basically has to be stopped. So there's just so many kind of physical barriers from that happening that are also in place, that I don't think everybody completely understands.
I think you're right. I think there is a lack of information out there, and that's why we're excited that you are with us today, because we found that people want to hear from men and women that work directly in the oil patch. They want to know and hear what you have to say. So we're glad we do this episode today.
Yes.
For the validity of the concerns, I can't tell you that every well that was drilled in the 1940s had the perfect wellbore integrity, but the criticism is, applied to modern development that has different regulatory rules, different processes that have been learned over time, and modern development is just going to be different and safer and more responsible. And for the criticisms, I think that modern development and modern technology and regulatory rules have moved towards protecting everyone. And I think everybody's on board with doing that. We all want to do the right thing. Like I said, raising families here, Midland, right next to, maybe less than a mile from where we're having oil and gas development, we're comfortable with that. And we know that those things are in place to keep us all safe.
That's a great point. Our smartphones have obviously increased since we first started carrying around bag phones back in the day when I first had one. And oil and gas is using technology and innovation and continuing to improve the processes. And what happened in the 1940s is nothing like what goes on today.
That's right.
As we approach 2030. One quick question. You get a permit? You have to get a permit to drill these wells? Is that right?
Yes.
Do you ever have to give any reports to the Railroad Commission?
Yes, we do.
Probably a lot of reports, right? My point is, all these pressures, all these volumes that you're producing, both with water and oil and gas. And so if there's a problem with a modern well today, this reporting process is going to find that out. There's inspectors that taxpayers are paying for, that oil and gas companies are paying for through permits and fees, but it's through the legislative process that goes out and makes certain that everyone is in compliance. And what happens if you're not in compliance? You either get fined or you can lose your permit to operate. And so it is highly regulated. And I think we're all very glad about that, because we need to have fair and consistent regulations.
Absolutely.
Well, we thank you both, Hunter and Nathan, for joining us today.
Thanks for having us. Enjoyed the chat.
Well, thank you again, Shana, Nathan, Hunter, for joining us on another episode of TXOGA Talks, where energy meets insight.
The views expressed on this podcast are not intended and should not be construed to be the views of any particular TXOGA member or company. The purpose of this podcast is to engage in candid conversations about energy needs, energy security, and the future of energy.